In this lesson, you will prepare a floor plan so that you can place spaces later. Because most MEP engineers work with a linked model during system design, you will first configure the linked architectural model, and then you will create a plenum level. Spaces allow you to calculate the volume of the areas in the building. They contain information about the locations in which they are placed. The information is used for heating and cooling loads analysis. Click the menu browser and select Open. And in the Open dialog box, from the Training Files Imperial Mechanical Systems folder, open the file RME MEP spaces 01. Let's configure the linked model for space bounding in order to begin designing systems in it. In the project browser, with the Level 2 Space Plan view active, select the linked Revit model. Then, from the Element panel, click the Element Properties drop-down and select Type Properties. In the Type Properties dialog, click inside the checkbox for Room Bounding and click OK. This makes the architectural components, such as walls, ceilings, and floors, recognized as boundaries for spaces. Press Escape to clear the selection, and next, we'll add a level for Plenums. In the project browser, under Design, MEP Design Elevations, double-click West MEP. Then, click the Architect tab, and from the Levels and Grids panel, click Level. Then, click the Change Element Type drop-down and select Level Plenum. Then, from the Draw panel, make sure Line is selected, and on the Options bar, verify that Make Plan View is selected, and click Plan View Types, and verify that only Floor Plan is selected, and click OK. This creates only a floor plan after the level is added. Then, for Offset, enter 8 feet. Then, click the left endpoint of Level 2, and then click the right endpoint of Level 2. This draws a plenum level 8 feet above Level 2. Click Modify, and zoom in on the right side of the elevation view. Then, double-click the level name Level 4, and enter Level 2 Plenum. When asked to rename the corresponding level views, click Yes. Then, press Escape to clear the selection. And note that you now have question marks under Discipline, followed by a set of question marks again. And under Floor Plans, you have a new Level 2 Plenum. Because we have not yet specified the view classification or subdiscipline properties, those categories in the project browser are listed as question marks. Right-click the view Level 2 Plenum and click Properties. In the Instance Properties dialog, for Subdiscipline, select MEP Plenum, and for View Classification, select Design, and under Identity Data, for Default View Template, select Plenum Plan, and under Extents, for View Range, click Edit. In the View Range dialog, under Primary Range, for Top, select Level Above Level 3, and for Offset, enter 0, And for cut plane offset, enter 1 foot and click OK twice. Now in the project browser, the view Level 2 Plenum is listed under MEP Plenum Floor Plans. Double-click the Level 2 Plenum view to open it. Notice that the site plan displays in the view. You'll now apply the default view template so that only the architectural floor plan displays. Right-click the view in the project browser and click Apply Default View Template. When you do, the view graphics are modified based on the template applied. Close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will place spaces in areas of the building model. Spaces contain information about the locations in which they are placed and allow you to calculate the volume of the areas in the building. This information is then used for heating and cooling loads analysis. Click the menu Browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Spaces 02. In the project browser, under Design and Spaces, make sure that the Level 2 space plan is active and zoom in to the empty room to the left of the corridor. Then click the Analyze tab, and from the Spaces and Zones panel, click Space. On the Element panel, notice that Space Tag with Volume is selected, and on the Options bar, Tag on Placement is checked, and for Upper Limit, select Level 2 Plenum. For Offset, enter 0, and make sure that Tag Location is horizontal, and Leader is cleared, and Space is New. Then, place your cursor in the room, and when the space snaps to the room bounding elements, the floors, walls, and ceilings, click to place the space. Then, to end the command, click Modify. Then, select the space, and from the Element Properties dropdown, click Instance Properties. In the Instance Properties dialog, scroll down to Identity Data, and for Number, enter 219, and for Name, enter Library, and click OK, and press Escape to clear the selection. The space number and name now match the room number and name from the linked architectural file. Next, we'll prepare the Plenum view. In the project browser, under MEP Plenum, open the view Level 2 Plenum. And notice that the software automatically zooms the new view to the same location as in the open view. Click the View tab, and from the Windows panel, click Close Hidden. Then, in the drawing area, double-click the section head in the library to open that section view. Then, from the Windows panel, click Tile Windows. Next, we'll place a space in the plenum. Click the Level 2 Plenum floor plan to activate it, and then click the Analyze tab, and from the Spaces and Zones panel, click Space. On the Options bar, for Upper Limit, select Level 3, and for Offset, type 0, and click in the library to place the space, and click Modify. Notice that the space is created in the section view at the same time, demonstrating the parametric functionality of the software. Select the new space, and from the Element Properties drop-down, click Instance Properties, and scroll down to Identity Data, and change the number to 219p, and change the name to Plenum. Then scroll down to Energy Analysis and select the checkbox for Plenum and make sure that Occupiable is cleared and click OK. Clear the selection and close the file without saving changes, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will place a space in a large corridor area and then split the space using a space separation line. This is beneficial to split up large volumes for equipment selection and sizing. Click the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEC spaces 03. Let's place a space in an open area. Make sure that Level 2 Space Plan is the active view, and zoom in to the central corridor near the stairs. Then, from the Analyze tab on the Spaces and Zones panel, click Space. On the Options bar, for Upper Limit, select Level 3, and for Offset, type 0, and click above the top stair to place the corridor space, and click Modify. Note that the new space is numbered 219Q. In the project browser, open the Space Schedule view and scroll down to the newly placed space, which was numbered 219Q. In the schedule, notice the corresponding architectural room name and number. Click the View tab, and from the Windows panel, click Tile Windows. Then, in the floor plan, double-click the space name and change it to Corridor and press Enter. Using the same method, change the space number to 216A. Notice that the schedule updates with the changes. If you had modified the name and number in the schedule instead, then the plan view would have updated with the changes. Close the schedule view and double-click the title of the plan view to maximize it. Then click the Analyze tab, and from the Spaces and Zones panel, click Space Separator. Then, to specify the start point of the separation line, click the endpoint of the lower wall in Space Instruction 221. Then move to the right all the way over to the curtain wall and click the perpendicular point. Then click Modify and notice the changed boundaries of the corridor space. Next, place a space in the lower area of the split space with an upper limit of level 3 and an offset of 0. When you do, the new space is numbered correctly to 216B. Click Modify and change the name of the space to corridor. Then clear the selection and close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will place a space in a chase and change the upper limit to account for the entire volume of the chase. Click the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEP spaces 04. Let's add a multi-level space. In the project browser, make sure that Level 2 Space Plan is the current view, and zoom in to the chase between the male and female restrooms in the north wing. Then click the View tab, and from the Create panel, click Section, and place a section in the view as shown. You may need to click Flip Section to reorient the section. Then use the lower drag control to change the section boundary. Then clear the selection and double-click the section head to open the section view. Instead of clicking Visibility Graphics, type the two-letter shortcut VG. In the Visibility Graphic Overrides dialog, on the Model Categories tab, under Visibility, scroll down and expand Spaces, and select Interior and Reference, and then click OK. Then, instead of clicking Tile Windows, type in the two-letter shortcut WT for Window Tile. Then, zoom and pan in each view as necessary in order to view the chase. And in the Plan view, click the Analyze tab, and from the Spaces and Zones panel, click Space. On the options bar, for upper limit, select Level 3, and for offset, type 0, and in the Plan view, click in the chase area to place the space. Then click Modify. Notice that you can see the space in the section view as well as in the plan view, but that the space does not fill the entire chase. Click in the section view and select the space, and right-click and click Element Properties. In the Instance Properties dialog, under Constraints, for upper limit, select Roof Level, and for limit offset, to enter the value that is above the level of the roof, type 4 feet. Then, under Identity Data, for name, type Chase, and for number, type 225 PC. Then click OK. Bounding elements such as walls, floors, ceilings, and roofs define the extent of space volume used in calculations. Because the chase space is limited by a bounding element, the space displays the volume up to the roof only. Press Escape to clear the selection. And next, we'll tag spaces. Open the view Level 3 Space Plan. Then, maximize the view and type ZF for Zoom to Fit. Then, click the Annotate tab and from the Tag panel, click Tag All. In the Tag All Not Tagged dialog, under Loaded Tags, select Space Tag with Volume and click OK. When you do, all spaces in the view are tagged. Close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will view and verify zones in the system browser. After spaces are placed in the building, Revit MEP immediately adds them to the default zone. Zones allow you to control the spatial environment and to perform an accurate heating and cooling loads analysis. Click the menu Browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Zones 01. It is good to note here that all space reference lines have been hidden in the training file to provide a clearer view of the floor plan. Space shading and space tags indicate spaces. To display space reference lines, you would go to the Visibility Graphics dialog, and on the Model Categories tab, under Spaces, you would click Reference. In the project browser, under Design, scroll down to Zoning, and you'll see that under Zoning Floor Plans, Level 2 Zoning is highlighted, indicating that it's the active view. Click the Analyze tab, and from the System Browser panel, click System Browser. When you do, the System Browser opens and docks to the right of the drawing area. The browser is a list of spaces and the zones to which they have been assigned. Default is currently the only zone. Right-click in the System Browser and move to View, and make sure that All Disciplines is selected. Double-click Default to display a list of the spaces in the building model. It is good to note here that a space cannot be placed into an area without being added to a zone. After a space is placed in an area, it is automatically added to the default zone. The recommended workflow is to add each space to a zone that you create, which removes the space from the default zone. The different graphics in the system browser indicate whether a space is occupiable or unoccupiable. You can change the occupiable parameter for each space. For example, 102 Conference has a green icon which shows that it is occupiable, whereas 101 Stair shows that it's unoccupiable. Let's change the occupiable parameter for a space. In the system browser, double-click 121 Cafeteria. In the Instance Properties dialog, scroll down to Energy Analysis and click inside the checkbox for Occupiable and click OK. When you do, the graphic in the system browser updates for that space, indicating that the space is now occupiable. Close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will assign spaces to zones in the building and verify the zones in the system browser. Click the menu Browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Zones 02. Let's assign spaces to a zone. In the project browser, scroll down to Zoning and note that Level 2 Zoning is the current active view. Then, on the Analyze tab, from the Spaces and Zones panel, click Zone. When you do, the Zone tool becomes active, the Edit Zone tab displays, and a new zone is created. The new zone is listed in the system browser. It is good to note here that the Edit Zone tab provides zone tools and information. You work with a single zone until you click Finish. Using the Edit Zone tab, you can add or remove a space from the zone and modify the zone properties. From the Edit Zone panel, click Add Space. Then, in the drawing area, select Computer Lab 222, Instruction 221, and Electrical 220. Then, click Finish Editing Zone. Then, to display the system browser, on the Analyze tab, from the System Browser panel, click System Browser. In the System Browser, expand the new zone and notice that the Computer Lab, Instruction, and Electrical spaces are added to it and removed from the default zone. To view the zone in the drawing area, you need to activate the zone visibility. With the drawing area active, type VG. In the Visibility Graphic Overrides dialog, on the Model Categories tab, under Visibility, select HVAC Zones. Then expand HVAC Zones, and then clear Boundary and Color Fill. Then click OK. The new zone displays with color fill and a zone reference line. The zone reference line indicates that the three spaces are in a zone. After you finish editing the zone, you can drag the zone reference line to relocate it and better view the spaces that are in the zone. Let's rename the zone. Select the zone, and from the Element Properties drop-down, select Instance Properties. In the Instance Properties dialog, under Identity Data, for name, enter 2 West Area B. Then click OK. When you do, the new zone name displays in the system browser. Expand the zone to West Area B to confirm that the three spaces are in it. Then close the system browser and close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will assign spaces on multiple levels to a zone in the building and verify the zone in the system browser. Click the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME Mech Zones 03. Here's a reminder that all space reference lines have been hidden in the training file to provide a clearer view of the floor plan. Space shading and space tags indicate spaces. To display reference lines, you would go to Visibility Graphics dialog, and under Visibility on the Model Categories tab, you would expand spaces and turn on reference. Let's create a zone for spaces on multiple levels. In the project browser, scroll down to under Zoning and note that the active view is Level 2 Zoning. Zoom in to Lounge 215, which is to the right of the central stairs. Then open the view Level 1 Zoning. Then type WT to tile the two windows. Then adjust the two views if necessary, and click inside the Level 1 zoning view to activate it. Then, from the Analyze tab, on the Spaces and Zones panel, click Zone. Then, with the Add Space tool active, in the Level 1 zoning floor plan, select Lounge 120 to add it to the zone. Then, with the Add Space tool still active, click in the Level 2 zoning view and add Lounge 215 to the zone. Then click Finish Editing Zone. Next, we'll tag a zone. Activate the view Level 1 Zoning and click the Annotate tab, and from the Tag panel, click Tag by Category. On the options bar, verify that leader is selected and that it is set to attached end and that the distance is 1/2 inch. Then click in the lounge space to tag the associated zone. Then press Escape, zoom out, and select the tag so that you can use the drag controls to move it as desired. The tag only displays in the view where it was placed. Because the heating and cooling loads calculations have not been performed, the tag displays not computed for those values. Let's rename the zone. Double-click the zone tag. In the Change Parameter Values dialog, click inside the Value field for Name Parameter and change it to Lounge East. Then click OK. Then press F9 to display the system browser. The new zone name displays in the system browser. You can expand the zone in the system browser to view the spaces in it. Then close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will verify the building, space, and zone information and view graphical representations of the spaces to verify space boundaries and volumes. Click the menu browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Analysis 01. Let's verify building information. In the project browser, double-click Level 1 Zoning to make it the active view. Then click the Analyze tab, and from the Reports and Schedules panel, click Heating and Cooling Loads. Let's view a space. In the Heating and Cooling Loads dialog, in the Preview pane, on the View cube, click the corner where the top, front, and left corners converge to orient the model. Then, on the View selector, located below the Preview pane, verify that Wireframe is selected. Wireframe displays the volume of a space measured by the interior boundaries. Click the Details tab and expand 1 South Lounge and select 109 Lounge and click Highlight. When you do, the space for 109 Lounge highlights in red. Click Highlight again to deactivate the Highlight tool. Next, click Isolate. The space displays while all other spaces are hidden. From the list of spaces, select South Lounge. Now all spaces in the zone display in isolation. Click Isolate again to deactivate the tool. Next, you will verify information that will be used during a heating and cooling loads analysis of the space. Select 109 Lounge, and below the list of spaces and zones, for space type, click Browse. In the Space Type Settings dialog, scroll down and select Lounge Recreation and click OK. For construction type, verify that building is selected, and for people, click Browse, and in the People dialog, verify that default is selected for occupancy and for heat gain per person, and click OK. Then, for electrical loads, click Browse, and in the Electrical Loads dialog, verify that default is selected for lighting and power, and click OK. Next, you will verify information that will be used during a heating and cooling loads analysis of the zone. Select South Lounge, and for service type, verify that building is selected, and verify that the heating, cooling, and outdoor air informations match this dialog. Next, we will use the shading view to examine the inner volume of the model for voids. On the view selector, click Shading. Then highlight and isolate 109 Lounge. Then deactivate the Isolate view and zoom to the corner of the building. Notice that there is a void in a second floor plenum space. Let's add a space to fill that void. Click Cancel to close the Heating and Cooling Loads dialog. Then, in the Project browser, under MEP Plenum Floor Plans, open the view Level 2 Plenum. Then, from the Analyze tab's Spaces and Zones panel, click Space, and on the options bar, for upper limit, select Level 3, and for offset, enter 0, and click in the empty plenum area to place the space, and then click Modify. Then select the space, and from the Element Properties drop-down, select Instance Properties, and under Identity Data, for number, type 212p, and for name, select Plenum, and under Energy Analysis, select Plenum, and click OK. Next, we'll add the plenum space to a zone. In the drawing area, select the zone that includes all plenum spaces for Level 2, which is named 2 Plenum. Then, from the Zone panel, click Edit Zone. Then, with the Add Space tool active, select the space Plenum 212p. Then, click Finish Editing Zone. Then, open the Heating and Cooling Loads dialog and verify that the space 212p under the zone 2 Plenum has replaced the void. Then, close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will specify project settings that affect heating and cooling, and you will perform a heating and cooling loads analysis. The report that is the result of this analysis allows you to determine the heating and cooling demands of the building. Click the menu browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Analysis 02. Let's specify project settings. In the project browser, under Design, expand spaces and floor plans and double-click the view Level 2 Space Plan. Then click the Manage tab, and from the Project Settings panel, click Project Information. In the Instance Properties dialog, under Energy Analysis, for Energy Data, click Edit. In the Type Properties dialog, for Building Type, select School or University. For Postal Code, type 03101. For Location, click inside the Value field, and then click Browse. And on the Place tab, select Automatically Adjust Clock for Daylight Savings changes. Then, on the Weather tab, verify that Use Closest Weather Station, Manchester Airport is selected, and click OK. Back in the Type Properties dialog, click OK twice. Next, we'll verify area and volume settings. Click the Architect tab, and click the Room and Area panel drop-down, and select Area and Volume Computations. In the Area and Volume Computations dialog, on the Computations tab, under Volume Computations, make sure that Area and Volumes is selected, and click OK. Then, zoom into the center area of the building, and select Space Library 219, and right-click, and click Element Properties. In the Instance Properties dialog, under Energy Analysis, verify that Occupiable is selected, and make sure that Condition Type is set to Heated and Cooled. For Space Type, click in the Value field, and then click Browse. In the Space Type Settings dialog, select Library Audio Visual, and click OK. For People, click Edit, and in the People dialog, under Occupancy, for Values, select Specified, then click Area per Person, and enter 50 square feet. And under Heat Gain per Person, for Values, select Specified, and for Sensible, enter 200 BTU. For Latent, enter 150, and click OK. For Electrical Loads, click Edit, and in the Electrical Loads dialog, under Lighting, for Values, select Actual, and under Power, for Values, select Actual, and click OK twice. Then click the Analyze tab, and from the Reports and Schedules panel, click Heating and Cooling Loads. In the Heating and Cooling Loads dialog, click the Details tab, and under To Middle Library, select 219 Library. The information for the space that you entered in the Element Properties dialog displays and can be modified here. Next, to perform a heating and cooling loads analysis, click Calculate. In the Loads report, under the Zone Summary for To Middle Library, click the blue hyperlink for 219 Library. When you do, you are taken to the place in the report where the space information is displayed for review. Close the report, and in the Level 2 Space Plan view, select 219 Library, and go to its Instance Properties, and under Energy Analysis, review the calculated loads and design loads. Then click OK and close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will assign a color scheme to a zone in the building. A color scheme allows you to communicate and identify parameters visually and spatially rather than by using space schedules or accessing element properties. Click the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Analysis 03. Let's assign a color scheme to a zone. The active view is Level 1 Zoning Load Fill. Click the Architect tab, and from the Room and Area panel, click Legend. Then click to the right of the building to place the legend. In the Choose Space Type and Color Scheme dialog, for Space Type, select HVAC Zones, and for Color Scheme, verify that Cooling Load by Zone is selected and click OK. Then zoom into the legend and notice that the cooling load is based on tonnage value in 1 ton increments. You want a scheme that allows for a greater tonnage range. Let's select a different color scheme legend. Select the color scheme legend, and from the Modify Color Fill Legends tab on the Scheme panel, click Edit Scheme. In the Edit Color Scheme dialog, under Schemes, select Tonnage Range and click OK. The new scheme, which displays in the view, allows for a greater range of cooling load values. Right-click in the drawing area and select Zoom to Fit. Notice that the colors are updated in the plan view to match the new color scheme. Let's apply a color scheme to a section view. In the project browser, under Zoning Sections, double-click Section 26. Then, from the Architect tab's Room and Area panel, click Legend. Then, click in the drawing area, and in the Choose Space Type and Color Scheme dialog, for Space Type, select HVAC Zones and click OK. Then, close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will create a schedule for the supply air system. Instead of placing this schedule on sheets as a construction document, you will use it as a design tool to determine whether the correct amount of airflow is being supplied to each of the rooms in the model. You will then use the schedule to adjust the air terminal workflow properties to more closely meet design requirements. Click on the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Analysis 04. Let's define the schedule. Click the Analyze tab, and from the Reports and Schedules panel, click Schedules Quantities. In the New Schedule dialog, under Category, select Spaces, and for Name, enter Space Airflow Schedule, and click OK. In the Schedule Properties dialog, under Available Fields, double-click Level. When you do, it gets added to scheduled fields. Next, double-click Number, then name, then calculated supply airflow, then actual supply airflow. Then click calculated value, and let's define the airflow delta formula. For name, type airflow delta. For discipline, select HVAC. For type, select airflow. For formula, click Browse, and in the Fields dialog, select Calculated Supply Airflow and click OK. Then add a minus sign after Calculated Supply Airflow and click Browse. Then select Actual Supply Airflow and click OK. Back in the Calculated Value dialog, click OK. Back in the Scheduled Properties dialog, notice that the calculated value, named Airflow Delta, displays under Scheduled Fields and will display as a column in the schedule. Let's specify additional schedule properties. Click on the Sorting and Grouping tab, and for Sort By, select Level, and then select Header and Blank Line. For Then By, select Number, then click the Formatting tab. Under Fields, with Level selected, click Hidden Field. Then select Airflow Delta and click Conditional Format. We will format the Airflow Delta field to display as red when the difference between the calculated and actual airflow is outside an acceptable range. In the Conditional Formatting dialog, for Test, select Not Between, and for Value, enter -25 and 25. Then, for background color, click the color swatch, and in the Color dialog, select Red and click OK. Then, click OK twice. When the schedule displays, notice that because no air terminals have been placed in the model, all the actual supply airflow values are 0, and all airflow delta fields are red for occupiable spaces. Later on, you will use the airflow schedule when adding system components to satisfy the required airflow. Close the file without saving it, as the next lesson provides its own training file, and that concludes this lesson.